Good afternoon. Today we'll be attempting to teach you thermodynamics. My name is Steve, and the book I will be using is The Fundamentals of Engineering Thermodynamics, the 6th edition, by Michael J. Moran and Howard N. Shapiro. We'll be solving a problem from this book from chapter 4. The title of chapter 4 is Control Volume Analysis Using Energy, and the problem we will be solving is problem 4.5, which reads: vegetable oil for cooking is dispensed from a cylindrical can fitted with a spray nozzle. According to the label, the can is able to deliver 560 sprays, each of a duration of 0.25 seconds and each having a mass of 0.25 grams. The question asks, determine the mass flow rate of each spray in grams per second and the mass remaining in the can after the 560 sprays in grams if the initial mass of the can is 160 grams. As you can see, I have already pre-worked out the problem and will now rework it with you. The first step was to draw a problem as you see here, demonstrating the can and the exit port or the outlet of the mass. I have drawn a control volume with this dotted line which surrounds the can and the nozzle, which means that all mass is contained within the can except for the outlet, which is demonstrated here. Now, there was some information given from the problem that should be recorded. The first information is that the retailer says that the can go 560 sprays, each lasting 0.25 seconds and having a mass of 0.25 grams. The initial mass of the vegetable oil is 160 grams. Okay. Now, we will first solve the first problem, which reads again, determine the mass flow rate of each spray in grams per second. Now, this is very easy to do, considering that they have given us both properties for each spray, which include the duration, which is 0.25 seconds, and how much mass each spray consists of, which is 0.25 grams. Now, the mass flow rate is equal to 0.25 grams, which is the mass of each spray, divided by 0.25 seconds, which is the duration of each spray. And that again gives us our mass flow rate, which is 1 gram per second. This right here is the answer to our first question. Continuing on to our second question, we will use the mass rate balance equation, which reads the time rate of change of mass, which is dm of the control volume with respect to time, equals the summation of the instantaneous mass flow rate of the inlet minus the summation of the instantaneous mass flow rate of the exit. Manipulation of this equation gives us the equation that you see here. This equation can be found on page 148 of the book that was previously mentioned. Now, since there is no mass, we have no flow rate. Excuse me. Since there is no inlet, we have no flow rate. So we could go ahead and cross that out and make it equal to 0.